Great, welcome to my presentation about Sonata. I'm Michael Bredel, I'm senior researcher at NEC, and I'm also acting as the overall technical coordinator of that project. So I'm trying to keep the zoo of developers together and work on the more technical side of the project. I'm going to talk about briefly about the objectives of Sonata. You have heard that already a bit, and then dive into the technical architecture of what we did, the software architecture and the software development kit and the Mono service platform, and then highlight some of the innovative parts, I guess, we have in Sonata, which is the customization of the Mono framework, then the infrastructure abstraction, Gatekeeper, and at the end I will have a brief, let's say, comparison between Sonata and OSM that was just created yesterday after I attended the OSM workshop on Monday out of my head because I did not have the slides unfortunately yet, but try to identify some similarities here. So Josep already talked about the DevOps approach, and I think one of the goals we have in Sonata is to come up with continuous integration and a CI/CD pipeline for network services, and then a combined development and operations for the network services. I mean, that's our goal in the end. Of course, we started with the deployment of our own architecture. So we said, hey, let's eat our own dog food and embrace the CI/CD approach and the agile development for our own development. Well, this is pretty straightforward for software companies. It's nothing new, but we had to work with operators, and not all of the partners were really aware of the consequences and not experienced in working that way. But in the last 1.5 years, we adopted that, and we already made a transformation towards a CI/CD approach also with operators. And we will use that knowledge and the experiences we gained to later also design and help design, let's say, workflows or help operators to migrate to that CI/CD workflow also for network services. So DevOps is not only a technical issue that you have to solve. I personally think that's even a minor issue we have to solve. It's a cultural and organizational issue that we have to address, and we need to support people to follow that. That's the Sonata architecture. It's a pretty complex picture, but don't worry, I will walk you through that a bit. So if you look at the picture at the bottom of that picture, let's see, yeah, in yellow, there's the virtual infrastructure manager. It's the virtual infrastructure we leverage to use and deploy services. In our case, it's OpenStack and Open Daylight. So that's just given. We don't work on that layer. We just use it as it is. On the right-hand side, you can see parts of the infrastructure that is the repositories and catalogs we use that become part of the service platform, but also can be standalone or can be part of the SDK. So that's why it's separate here. And on the left-hand side, we have the SDK. So all of our deployment and development tools that we give to service developers and VNF developers that they can bring and package and develop their network function such that it can be used with the Sonata service platform. And the big part in the middle, that's the Sonata service platform, and I will dive into that a bit as well. So this SDK part and this service platform, these are the main components of the overall architecture that we have. So looking at the SDK, for us the SDK right now is a set of command line tools that allow service developers to work with network functions and to create network functions. So something like creating a workspace, as you may know it from Java Maven. We have tools, and there will be a dedicated talk on that deal with testing and emulation of the VNFs and stuff like that. So you don't need to have the service platform at hand, which, well, installing an OpenStack testbed and Open Daylight on top or side of that can be a hassle. So if you want to start development, you don't have the resources maybe to do that, or you don't want to do that, but you still want to be able to develop the service, and we provide you an environment to do that. Then there is a packaging tool that creates a package which can then be sent to the service platform, and there's a tight integration between this SDK part and the service platform tool. So as said, emulation testing, that's something that we are working on. It's part of the SDK, and the integration with the service platform goes via the catalogs and the repositories we have in the service platform. You may ask, okay, well, command line tools, why just that? Why not a fancy GUI, as you can see downstairs with a lot of the products? Well, command line tools, if you talk CI/CDs, command line tools became very attractive again for developers. I guess most of the developers, software developers now, we're using these tools already. So the thing is that you can easily integrate a command line tool, a CLI tool to a CI/CD pipeline. You can script around it. You can easily use it. It's much harder if you do that with a GUI. And there are prominent examples around today, like Docker just creates a management framework for for managing namespaces on Linux. And there are other tools like for the web development, like Node.js Grunt. They just command line tools that help you develop things, and so are the SONATA SDK tools. The service platform, on the other side, is much more, more complex, has more components at least. It's based on microservices, and all the microservices, all the applications that run in Docker containers. So each component of our service platform, and there are around 25 different components, are encapsulated in a container, and all the components communicate via a shared message bus. That has several advantages for us. First of all, during the development time, because we can develop all the different components independently from each other. So you can look at one component and you can easily mock it up. You can you just need to talk to the APIs of that component, but it's totally independent of the development of a different other component. And as Josep mentioned, we are 15 partners spread across whole Europe, so it's really important that we can work independently. If you package it in a container, it's easy to deploy, it's easy to update, it's kind of easy to manage. There are nice tools out there that help you to do that. And it's easy to scale out, so the platform inherently became scalable. We don't need to do much about it. Well, that's not true. We have to think about it. But in general, it's easier than if you create a monolith. We can test all of the components, again, individually. So we can test component by component on its own. We can also do integration tests, and we can automate that easily. Another important factor when it comes to the operations of the SONATA platform, or let's say putting it into a more production-like environment, it's flexible. The components are flexible. You just need to know the API, and then you can exchange the different components. So if you think, hey, this component A written by one of the partners is not really great, it's slow and, I don't know, buggy, then you can easily exchange it. You can easily come up with your own component. You just need to obey the APIs which are kind of well documented. And we can also integrate new components quite easily. I just need to make sure that they can talk to the message bus and interconnect them with the other components. It's not that I need to redo the whole architecture, change the architecture. If we want to introduce something new, what we think will be important in the future. And finally, this architecture helps us to test it automatically and build a CI/CD pipeline using Jenkins. So that's what Josep also mentioned already. It's open source, so everyone can contribute to that. It's on GitHub. You just need to fork it and create a pull request, and it will be, once you create the pull request will automatically be tested. It will be automatically built, and if that is successful, then there's a high chance that it will be integrated into the service platform. So that works automatically, all of that is supported by the service platform architecture as it is built on Docker. So how does it look like? Well, a bunch of Docker containers running independently, having all the different things that we've developed, but also things that we just reused, like the RabbitMQ, for example. That's a server application, the message broker application that we just use. It's also used, for example, in OpenStack. So it's new. We use databases, Prometheus databases, and all of these components run in the different Docker containers. Most of them communicate via the message broker or via RabbitMQ. So let's further zoom into that service architecture. So in the next couple of slides, I will talk a little bit about the customizability of the service platform. That relates to what we call ServerSpecific managers and function-specific managers, FSMs and SSMs. I will briefly talk about the Gatekeeper, but there will be a dedicated talk on the Gatekeeper and its functionality after that. So just to give you an idea and to locate it in a overall service architecture, and the infrastructure adapter. But of course, there are much more things that would be interesting to talk about. Due to the limited time we have, I just focus on the red boxes here. But you can find a good documentation of all this stuff on GitHub as well as on our website. We spend quite some effort to make it transparent what we do, to make it transparent why we did it, and how the architecture looks like and all the components look like. So it's easy to find more information about all these components later on. We have a pluggable architecture and the different components do have various interfaces, and we tried to come up with this picture that map our interfaces to the ETSI reference model and the interfaces that are described there. So it's not really a one-to-one mapping all the time. That's because when we started, the ETSI architecture was, the architecture was fine, but the description of the various APIs and interfaces were not fixed yet. It's becoming more and more mature now. But we had to extend, and since we really wanted to build it, we had to play around with it and make it work in the end. Right? But it's possible to map that to the ETSI architecture, so you can have a separation, for example, between the NFVO and the NFVI and stuff like that. Now the customization using plugins. We call the function-specific and service-specific managers. So if you have assume that you have a network service that is comprised of two different network functions, a firewall and a traffic classifier in that case, just as an example, right? It's chained up, so you have a service chain between, and that's what you usually call a network service in the VNF world. Now what we add is a function that's basically the data plane, right? So that's where you forward packets and process packets. So what we add is a function-specific manager. If you think of Etsy terms, that might be an EMS, kind of, right? It connects to the network function, and it connects the network function to the service platform, and it allows you to do configuration and stuff like that. In addition, we have a service-specific manager that now not talks to a single VNF, but that can operate or manage the whole service. These FSMs and SSMs, for example, can be used to support upgrading and updating of these functions at runtime. That would be one possibility. And that's the control plane. So we use these functions to connect our virtual network functions to the service platform, kind of. And the important part is that these SSMs, FSMs, they can be developed by a service developer. They can be shipped with a network function within the package to the service platform. And in the service platform, they look like any other component in the platform. They are executed as Docker containers, and they just plug in to the service platform as any other component. Don't ask about security yet. We are looking into that. But right now, we just wanted to make it happen. So there might be some security issues there, but pretty sure that we can deal with them. We have some ideas on how to address that. Another important component is the Gatekeeper. That's the central point for external applications developers to connect to the service platform. We have a GUI developed so that you can have a look at what is going on the service platform easily, but also the SDK connects to that. And it's the central point also to accept packages, VNF packages, and manage the onboarding process. So verifying, validating the package and stuff like that. In general, it's an interface that allows you to connect to the service platform. And that will become important later on when we talk about recursiveness of the service platform. Another important point is the infrastructure abstraction, or the infrastructure adapter in our case, which abstracts the Vim and the Vim, the wide area infrastructure manager, as well as the virtual infrastructure manager, in a way that we are vendor agnostic. So we use OpenStack right now, but in general, we can use any other, we should be able to use any other infrastructure here, like VMware and stuff like that. So it's, again, just a plugin that you need to develop that translates the general API and the general messages to the messages that are understood by the virtual infrastructure, by the infrastructure. And right now, we support OpenStack. We are discussing what else to support. So candidates are not only virtual machine infrastructures, but also container infrastructures. So it might be that we, in addition to OpenStack, support something like Docker or Kubernetes or something like that. That's under discussion right now. And here, again, it's a pluggable architecture. So it's pretty easy to come up with something new and plug it in, and it works out of the box. Sonata supports recursiveness. That was one of the general architecture ideas we had right from the start. And there are two different ways of recursiveness that you can have, or two flavors of recursiveness. One is recursiveness of descriptors. Say when you describe your VNF, there can be, I will show that, explain that to you in detail. There can be a recursive operation in there, and the recursiveness of the platform itself, which will be addressed by a different talk. So what do we mean by recursiveness of descriptors? Well, you can have a VNF, a firewall, and a traffic classifier, and you create a network service out of that two VNFs. Now you want to use this network service again as a network function in an even more complex service. And this is supported by Sonata, and we elaborated a lot on that because when you're going back to the DevOps and agile way of development, what we actually want to do is to reuse components. We want to, as a software developer, you don't want to do everything on your own. You want to be more like object-oriented or using libraries, right? You want to reuse components, and Sonata is addressing that issue here. It's not as straightforward as you might think. It has a lot to do with identifiers, identifying the right component, addressing the right component, and aggregating them. So that's the one type of recursion that Sonata supports. And the other one is that you can run Sonata on top of Sonata, kind of. Not implemented yet, it's future work, but it's an idea that we are following, that you can have a hierarchy of Sonatas that are operated by each other, basically. Sonata and OSM. I was in the OSM session on Monday, and I was following closely what they did, and it was pretty interesting for us. So if you compare both of the tools so far, they are both open source under Apache 2. So all the components we developed are under Apache 2. Same for OSM. There's a one-click installation. The OSM guys showcased that. So there was a short demo where they did the installation. Same for Sonata. It's pretty easy to install it. You just need to download one script and execute it, and then it downloads all the containers you need, and half an hour later, the system is set up. Extensive documentation. We really put some effort in documenting stuff so that it is easy for you to become part of the Sonata ecosystem, or at least try it out, so that you can download it and that you play around with it and understand what is going on. They both are based on Docker. They are based on Docker, right? The service platform is using Docker in both cases, which makes sense, right? It's the way you are doing microservices, the way you're handling microservice architectures today. And we both worked on descriptors. We were more following the Etsy descriptors. I think, correct me if I'm wrong, OSM is more using Tosca. But no, it's also Etsy. I see someone shaking his head. Anyway, the descriptors that needed some work to actually work in a real world environment, right? They were really theoretically at the time we started, and becoming more mature now, but we needed to tweak them a bit. And there's packages and package management to onboard stuff, same in both of the components. And finally, there's an SDK that has a service platform emulator. That's already in Sonata. That's not yet in OSM. But that's actually the collaboration we are right now discussing with the OSM project to see how we can support that and bring this idea of that emulator to the OSM. Okay. That's basically it from my side. Sonata deals with the DevOps and CI/CD idea for network services, and we are addressing that. We have built an open source architecture that you can download and use, and it's well documented, based on a microservice approach. We did a lot to create reusable artifacts. And Sonata is available on GitHub. So just go there, download it, and let us know, provide us feedback, what you think. Yes?
Just one question. You have, in the orchestrator part, you focused on service level there. Some functions as well. But have you also looked into the separation of the orchestrator into the network service and also resource orchestration?
Yes. So that's in the picture we show. It's not the separation is not that clear, right? But you can map it to the Etsy thing. It's just a different way of showing it. In fact, let me maybe. So there is. So here we have the VNFM part and the NFVO part. So we do have that separation. Yeah.
That's not my question.
Okay. Sorry.
So there is an ongoing discussion in Etsy where they said that the orchestrator, that is one block now, but maybe we could look into scenarios where a network service orchestration could be separated from a resource orchestration. And the resource orchestration is then working with multiple VIMs because you could have a multi-site of a service and then we need to have some coordination there.
Yep.
Have you looked into that as well, or is that a little bit transparent for you at the moment?
No, we looked at that, or we addressed it as well. So what we can do is, so a Vim for us is one Vim is one block. So we don't look into the Vim like how OpenStack does resource management and placement and stuff like that. So the Vim is one building block here. But we can support multiple Vims. So meaning you can have multiple sites. Now all of these sites have to use OpenStack, but it can be separate sites, separate POPs if you like. And we can distribute, well, let's say we are working on distributing the services across multiple POPs. So we would say it's multiple POP, not multiple Vim. Multiple Vim would be different Vims for us. But multiple POPs are possible, yes. Yes, another question.
I have a couple of questions. First question, you mentioned Sonata on top of Sonata. What is the use case for that?
There will be another demo. I would just refer it, another presentation right after mine. So it's, I would just refer it to that presentation.
Another question, how do you deal with state of the VNFs?
Yes. Right now, we don't on a service platform level. So there's no support for state migration, for example, when you scale up or when you scale out or when you do upgrades on the service platform. We are looking into that. That's one of the things that we have in mind. We have it in our heads, but we don't have a solution yet. It's OpenNF, maybe some support for that in the service platform already, but no final answer to that.
Okay. And then a last question. If I remember well from the OSM workshop, they had, I think, support for OpenVim instead of for OpenStack, or at least there was OpenVim support because that has advantages in terms of detailed assignment of VMs to particular cores, etc., to better have better SLA assurance. But I understand that Sonata is only OpenStack so far.
Yes, so far. I mean, they have like OSM supports OpenStack, OpenVim, and VMware. And I guess VMware developed the connector to VMware. that's the partner that's missing in our consortium. So right now, the architecture allows you to plug in different, let's say, translators or connectors to different VIMs. But due to a lack of resources, we just have OpenStack right now. Okay. Thank you very much. And then